All right, these are the notes for 8-7. This isn't anything new, it's just applying the trigonometry that we've been studying. So suppose an operator at the top of a lighthouse makes a 2-degree angle with a horizontal line. At the same time, a person in the boat must look 2 degrees above the horizontal to see the tip of the lighthouse. So let me start here. Here's the person. Okay, if you look straight ahead and then look down onto the ground or something, you'll feel your eyes move a certain number of degrees. This is called the angle of depression. So right here is the angle of depression, right here. From the horizontal, you're straight ahead. How many degrees you lowered your eyes is the angle of depression. And in this problem, that is 2 degrees. The top of the lighthouse is 25 meters above sea level. So this is 25. And they're looking for the distance between the boat and the lighthouse. And excuse the drawings, I know they're not very good. Well, the lighthouse and the ground are going to make a right angle. I'm never going to fool you with that. You can see the horizontals. Well, they're parallel, so by alternate interior angles, this is also 2 degrees. And I know that that is 25. So your next part is we're trying to find this. Now you can go through your toolbox. Can I use Pythagorean theorem? No, I can't use Pythagorean theorem because I don't have 2 sides. Is it a special right triangle? No, not a special right triangle. That's not going to work. So instead we're going to have to use our trig functions. So here's the angle I know, 2. I know the side opposite and I know the side adjacent. So which function, trig function, goes with opposite adjacent? Hopefully you say tangent. Now you can do that from 2 degrees, but it's a little easier when I have the angle opposite the missing side. So I'm actually going to go over here and find that angle. That's 88 degrees. And the way I determined that was, well, this is 90. That's 2. The sum of the angles of a triangle have to be 180, so that has to be 88. So I'm going to say the tangent of 88 degrees equals x over 25. I'm going to multiply both sides by 25. And then I'll just do that work on my calculator. So you guys should be pretty good with that by now. So I got 716 meters, or 715.9, depending how you did it, but about 716 meters. And again, make sure that makes sense when you look at it. Look at this. This is a 2-degree angle. Think how very small that would be. And that was 25. This angle is 88 degrees. That should be significantly bigger. And that looks about right at 716 meters. In the next problem, I drew a picture. Poorly, but I drew one. We have that the person is 1.5 meters tall. And that he's standing 20 meters from the building. And here's his horizontal, so there's the horizontal. And then he's going to angle upward. So this is called an angle of elevation. So he has to look up a certain number of degrees to see the top of the building. And they told us that the number of degrees he had to look up was 58 degrees. Again, this is a right triangle. If this is 20, well then so is this. That's 20 also. And we're looking for the height of the building. So I'm going to start with, here's 58. I can find this side. So I'm going to say the tangent of 58 equals x over 20. Solve that. And when you solve that, I believe you get 32. Let me just double check my work. Yep, so we get x equals 32. Now that's not the height of the building, remember, that's this part. So now we need to take that 32 and add on the 1.5 of the height because the person is elevated. So the height of the building is actually going to be 33.5 meters tall. In the next one, the sun's angle of elevation is 38 degrees. And that depends on time of day. So if we if we say if I was here, from the horizontal up, the angle of elevation is from the horizontal, how much you had to angle up. This is 38 degrees. And so is this. And this is a right angle. And they also told us the building casts a shadow of 45 meters. So here's the shadow down here. It would be on the ground, 45 meters. How high is the building? I'm looking for this. Again, I was given the 38-degree angle and opposite and adjacent to that. So the tangent of 38 degrees, I chose tangent because I had opposite adjacent, and that's the opposite adjacent ratio is tangent. Equals x over 45. Multiply both sides by 45. You should be very good at this by now. And get about 35.2 meters tall. All right, for the last one, from the top of a lighthouse 20 meters high. So again, we're told this is 20. We know how high the lighthouse is. A sailboat is sighted having an angle of depression of 4 degrees. Now, that means angle of depression means the amount from the horizontal, that's your straight ahead, how many degrees you lowered your eye. So this is 4 degrees. The angle of depression is from the horizontal down. Not the vertical, the horizontal down. So since this is 4 degrees, alternate interiors are congruent. This must be 4 degrees. This is my right angle. Again, I'm looking for how far the lighthouse is from the boat. I was given the opposite. I have to find the adjacent. Opposite adjacent is a tangent ratio. Since I like working, you can do the tangent of 4 equals 20 over x. You'll still get the same answer. I'm going to use this one because I kind of like having the x across from the angle. And the 86 is just from the sum of the angles of a triangle must be 180. So I'm going to say the tangent of 86 degrees equals x over 20. I'm going to multiply both sides by 20. And I'm going to go there now. So I get x equals 286 meters. And that concludes our application for trigonometry.